Hello everyone. So today let's solve the problem number 695, maximum area of the island. Yeah. So let's see what the question states here, man. Yeah. So we are given an m into n binary grid, right? So binary grid in the sense that consists of only this one numbers 0 and 1. Yeah. So see here, we have been given a this one, what do we call m into n binary grid, where 1 equals land and 0 equals water, right? An island is any group of ones connected four directionally. An island is any group of ones connected four directionally. So we have to return the size, nothing but the number of one cells of the largest island, right? So we have to return 0 if none exists, right? So just remember this one. An island is any group of ones connected four directionally. We have to return the size, nothing but the number of one cells of the largest island. So we have to return 0 if none exist here. So we will use a we'll be making use of the graph approach. So again, so m into n binary grid where one is nothing but here, one they have marked in the yellow, right? So this one is nothing but the land and 0 is nothing but the sky blue. They have mentioned basically it is water, right? So an island is any group of ones that is connected four directionally. See here, four directionally in the sense, so we can just this one, up, down, left or right. So this is four direction, right? So an island is something that is connected four directionally, either whether it may be up, down, left or right. So this is fine. Yep. Now we have to return the size. We have to return the size, nothing but the number of one cells of the largest island. So we have to consider the largest island and we have to return its size actually. We have to return 0 if none of them exist, right? If the line doesn't exist at all, then we have to return the 0. Yeah. We will use a graph approach. So like we can make use of the graph approach here, right? So this is graph itself basically. Yeah. We can just treat the cells as nodes and four direction edges between the adjacent land cells. Yeah, we can just go with a graph approach here in simple terms. Let's do one thing. The previous problem we went with the BFS actually. For this particular problem, let's go with the DFS. Recursive, or let's go with the iterative DFS for a change. Yeah. So this is fine, I believe. Let's consider the same example. So here, see, before considering the approach, see, all the group of islands we have to consider. So this one we will be considering here. Uh, this one is simple one. So we will be going with the DFS, right? So first thing, what we will be doing here. So I'll just consider the same first example here. You can just implement or you can try to implement by considering the second example. Yeah. So first, we'll start from here. We have 0, we have 0, we have found 1. So first, we have found 1 here. We'll check left, right, up and down one step. Only we can check one step at a time, right? So down, up there is nothing, so left and right we have 0 and down we have 0. Yeah, diagonally we cannot move. So we have found this one, so this one group, so this is 1, right? So then what we'll do, we'll consider one variable, and whenever we have found the group of ones again, so we will be incrementing that one. Yeah, so not will be incrementing, so we'll just yeah, we'll be going with a +1 actually. Yeah, so we have found 1 here, so let's go with the second one. We have found 1 here, so we will check left and right we have 0, right? So left and right we have 0, and left we cannot, right? So as we are considering this one, left and right 0, so this is fine. Down we have 1, so we'll go down. Next we have right, we have 1, and right we have 1. Yeah, so again we'll check right, left to this one we have 0, and down also we have 0. Diagonally we cannot go, so this forms another group, and this one will be going with a +1. Yeah, so next what we'll do, we'll come here to this part, the third row, right? So the third row and the second column actually. Yeah, so this one we will come here. So we'll check left, no one, up, 0, right we have 1. Yeah, right we have 1, so this is fine one. Yeah, we have found 1. So then for this one we will also check down, right? Up, left, right and down. Right we have found 1, down also we have found 1. Again left and right we check, we have we don't have any ones. So down we have another one, to this particular one. Yeah, we have found this another group, so we'll go with 1 plus 1 plus 1 here, right? So next what we will do, we'll go with one more, this one. So we'll start from here, left and right 0, up 0. So down we have found 1, down we have found 1 again. So for this one right also we have found 1, for this one right also we have found 1. Yeah, left is 0 and 1 we have already visited. After visiting the cell, we will just mark them as visited actually. we'll mark them as visited, or we'll convert them that one to the 0 actually, right? Also, or we'll mark them as visited. Either of them we can do, right? So we can just convert that one to the 0, or we can just mark them as visited by considering X or something. Yep. So this is fine. Yep. So this is fine. This also forms one group, and we'll be going with one more one here in this case. Yeah. So now, so here in this case, this one. So now we have come to this part actually. So this one we cannot. So basically we can consider this one actually one. So here we'll be going with this one and this one as well. So and yeah, so we can just go with the right append. So this one also forms one, right? So this one also forms one actually until here. So we cannot consider this one because it is diagonal, right? So this one will be 1, 2, 3, 4, 5, 6 actually. So this also forms one. This is fine. Finally, what we'll do, we'll go with this one. We'll start with this one. So basically one, we have found right one, again the right one, the down, and for this one, right to this right, this one also forms one group, right? So this one is 1 plus 1 plus 1. So this one total we have here as 6 actually, 6 elements, yeah. So we have found the 6 elements. Just give me a second here. Let me delete this one here in this case. So we have found the 6. So this one, we cannot consider this one. So here we have found total 6, right? 6 elements actually. So within the 6 element, for this one, we have only this one area is 1. So for this one, the area is this one only 4. So this one, the area is 5. This one. So the area is 1, comma, max we will consider, right? So max of all the islands that we have found, this one area 1. So this one is actually 4, and next one, this one is also 4 actually. You can just count. This one is 4 actually. This one is 5. 1, 2, 3, 4, 5. So this is fine. Sorry, this is 5, right? So yep. So for this one, it is 6 actually. You can just consider 1, 2, 3, 4, 5, 6. Yeah. So this one is 6, and this one also, this one, for this one also, it is 5. So max of this one, 1, 4, 4, 5, 6, 5 is nothing but 6, right? So this one is having the maximum area actually. The maximum area is 6. Basically, we have to display 6. Yeah. So the output that we got here is 6, which is equivalent to the output that they have mentioned for the example within the question. Yeah. So our approach works absolutely correct here in this case, right? So we will be performing DFS actually. We'll be finding the number of islands, and then uh, we will be going with a max of this one, all the islands, this one area that we have found, right? So that one will give us the maximum area. So we'll be considering the maximum value basically, right? So the answer is not 11 because the island must be connected 4 directionally they have given. So for this one actually, don't get confused here. So we cannot consider diagonally, right? So these two are different islands, yeah. So this one cannot get, so this one will not get connected to this one, yeah. Diagonally we cannot connect, yeah. So either we can connect up, this one down, left or right. So we can just go with this one, this one, this one, or this one. This one we already have. So diagonally we cannot go. These two islands are different. So this one is different and this island is different as well. Don't get confused here, right? So that's what they wanted to say. Let me, yeah, let me show you the same thing. So this is fine, man. Now we have the idea. So one thing, for the previous problem, as we have went with this one, BFS, let's do one thing. As I've said, we have already discussed this one. So we will be going with a iterative DFS to solve this particular problem. Yeah, iterative DFS to solve this particular problem. So iterative DFS uses stack, right? When we are going with iterative DFS, we'll be making use of the stack as well. So now this is fine. Let's make use of the DFS to solve this particular problem. Let's see how can we write the code basically. Yeah. Now, what will be the time complexity and the space complexity for the code that we'll be writing basically? The time complexity would lead to big of m into n because every cell is visited at most once. Yeah. So every cell will be visited at most once. Every cell, each cell in the grid. Yeah. So overall time complexity would lead to big of m into n. So what will be the space complexity here? The overall space complexity would lead to big of m into n as well. Yeah. So overall space complexity would lead to big of m into n as well. Why? In the worst case, the we'll be making use of the visited array. So we have to mark the visited cell, right? So we have to mark the cell as visited once we visit that particular cell, right? So we'll be making use of the visited array. Plus, we'll be going with the DFS stack. right? So as we are going with, as I've said, we'll be going with the iterative DFS. So we'll be making use of the stack. So we'll be going with the DFS stack along with the visited array. So which in worst case, all the land can grow up to big of m into n, right? So overall space complexity would lead to big of m into n as well. Right, so the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach and the complexities part, let's start writing the code. So first, let me go with here, this one. Let's get the row count and the column count first. Yeah. So first, let's get the row count here. So I'll just go with grid dot length. So this is fine. So before moving on with the column count, actually, if no rows, then no island at all, right? So suppose if m equals 0, if no rows, then no this one, no island at all. So in that case, let's return 0. Oh, this is one of the this one important things as well. Let's go with the number of columns in grid. So now int n equals grid of this one 0 dot length. So this is fine. So the next step would be, so let's go with a visited marker to avoid the revisiting nodes, meaning, so let's consider the visited array here. So this one will be Boolean. So this is fine. Red equals new. Let me go with the Boolean of m into n respective of size assignment and respective. This is fine. Let's make use of the variable just to track the maximum area that is found. So initially, let's initialize that one to the 0. I'll just go with a max area here. Let me initialize this one to 0. Yep. So this is just the result to return. This is fine. Now let's iterate over every cell, meaning each cell in the graph node. Yeah, same thing. Two for loops here. So this one will be int I equals 0, I less than m rows, right? I plus plus again for the columns for j equals 0, j less than n, the columns n, right? J plus plus. Yeah. So let me consider int here, or else we'll be getting the error. So this is fine. Within these, within the for loop, basically, if the cell is land, nothing but one and not yet visited, we have to start the DFS to compute its this one, compute its component, basically. Yeah. Also, this one, we have to compute its area, right? Its component area, basically. How can we write that one in the form of code? Let me go with if grid of ij, if it is equivalent to the one and not of visited, so this one of I and j, this is fine. Within the if condition, let's calculate the area using iterative DFS, nothing but the stack. So I'll just go with area equals, let's do one thing. For this one, we have to perform the this one, what do we call? DFS, right? So to make use of the DFS within the main method, let's write the helper method DFS first. So I'll just come here. So let's do one thing. Mm, yeah, let me come out of this one entirely. We have to return something here, right? So maximum area we have to return. We have considered this one. So let me leave space here as well, here as well. So now let's go with the helper method, nothing but a DFS, right? So let me name this one, this one. Wait, void. Sorry, we have to go with the integer, not the void. So this one has to be a DFS iterative. So let me name this one DFS iterative. This makes sense as we are going with the iterative DFS actually. This is fine. Let me go with here grid. So this is fine. Boolean. Let me go with visited BIS. So this is fine. Int SR, int SC, as well as int M, nothing but rows, and int C, nothing but int M and int N, not the C. And nothing but for the column. Yeah. So now let's go with a stack that's implemented with array DQ for the base row and column. So I'll just go with array DQ here. So I can just write it in this way, man. Int. So this is fine. Let me go with stack here. This is equal to new array DQ. So let me complete the syntax here. This is fine. Now let's push this one. Let's push the starting cell. So I'll just go with, as we are making use of the stack, let me go with stack dot push, the push operation provided by the stack. So this one will be new int of let me go with SR and SC, row and columns, right? So we are just pushing the starting coordinates here. This is fine, man. Yep. Now let's do one thing. Let's move on with the further things here. So this one, mm, let's mark the starting cell that's visited. So this one will be visited of SR and SC. So let me assign this one to the true man. Yep. So this is fine. Now let's go with the area counter for this connected component. Nothing but let me initialize area to 0. Initialize area to 0. Now let's go with the direction vectors for up, down, left, and right. So this is nothing but the 4 directional adjacency. So I can just write it in this way. We have used this one in a number of problems. So I'll just go with directions dirs. Let me assign this one to the first. Let me go with 1 comma 0. Next, let me go with this one minus 1 comma 0. So this is fine. Next, let's go with a 0 1 here. Let's go with a 0 1, and finally let's go with a this one 0 minus 1. Yep. So we are done with this part as well. Now let's go with a this one. What do we call standardized this one DFS loop. Yeah, let's loop while there are nodes to process actually. So this will be while of stack not empty, right? So I'll just go with is empty. So this is fine. So within the while loop, let's do one thing. Let's pop top of the stack. So I can just make use of the pop operation, right? So I'll just go with current here. This one will be stack dot pop. Yep. The next step would be we have to consider the current row, current column. Along with this, we have to count the land cell towards the area. So whenever we have found the land, we have to increment that one, right? That's what I showed actually within the approach. So I'll just go with here int r equals current of 0. This is fine. And c equals current of this one 1. This is also fine. Finally, we have to count the land cell toward area, right? So I'll just go with the area plus plus. Yep. So now let's do one thing. Let's explore the 4 neighbors, right? So let me go with a for loop here. Int d of, let me go with the directions. This is fine. So within the for loop, we have to go with the neighbor row and neighbor column. So for the neighbor row, I'll just consider nr. So this one will be r plus d of 0. Yep. So for the neighboring column, let me consider nc, the variable nc. So this has to be c plus this one, d of 0 again. Yeah. So d of 1 we have to consider for this one. Yeah. Sorry. This is fine. Now, after doing this neighbor row, after considering neighbor row and neighbor cell, so this one, let's check the, let's go with the this one bound check actually. Let's check the bounds and whether it's unvisited land. Let's check for these two things. Yeah. So let's go with bound check first. So this one nr greater than or equal to 0 and nr less than m. So this is fine. NC greater than or equal to 0, and this one NC less than this one neighboring row less than column. So this is fine. And also we have to check whether it's unvisited, whether we have, or whether it is an unvisited land or not, right? So this one not of visited of this one, let me consider NR and NC. NR and NC. mm, NR and NC, and let me go with here grid of NR NC, mm, NR NC, if it is equivalent to the 1, if we have land, and if it is not visited, then what we have to do, we have to mark the this one neighbor visited to re-adding the same thing, right? So I'll just go with a visited of neighbor row, neighbor column. Let me this one set this one to boolean value true, and let's push the neighbor to stack to explore later. So I'll just go with the stack dot push here. In this case, new int of new int. So this is fine. So let me give here neighboring row as well as the neighboring column. Yeah, so this is fine. Yep, now we have successfully pushed the neighbor to stack to explore later. Yep, this is fine. Now let me come out of this one entirely. So all I have to do is we have to return the computed area for this connected island, meaning we just have to return the area here. Area is the keyword that I have considered, or the variable that I have considered. Let me format this one. So we are done with the DFS part, iterative DFS. So let me copy this one and let's make use of it within the this one main method. Yeah, main method, or what's the name of the function here, or the method maximum area of island. This one. Yeah, so let me paste this one, DFS iterative. So what are the parameters that I need to pass here? So this one we have sorry, what did I give here? Sorry. This one we have grid, we have visited. So let me give here, let me type here. Grid is fine, visited. So I, J, M, and N respectively. Yep. So this is fine. Let's update the maximum area that we have found. See, I can write it in this way. If area is greater than max area, then we have to set the max area, or we have to assign the max area to the area, right? So this is fine. Finally, all we are left with is this one. We are left with returning the this one max area. We have to return the largest island area, nothing but 0 if none found actually. In this case, let me go with return max area, right? So this is fine. So let me format the code and let me hit the run button. So this has to work accordingly with me. Int equals. So this is wrong one. Line number 30. So let's go to line number 30. So let me run this one again. By mistake, I have typed this one. What happened here? Oh, this one has to be this one. Flower braces month. Why did I give? This is fine. Yep. So now let me hit the run button again. Now this has to work. No. Boolean cannot be converted to Boolean. This one. TFS I tried visited. Where is visited here? 1 second. 1 second. 1 second. Let's see this one. Boolean. This is fine. Boolean array. So yeah, this one we have. Oh, we have considered this one. This is fine. Let me consider this one. 2D grid, right? So let me run this one again. So we were, yeah, now the sample test cases are getting passed. So this was the main thing actually. This is fine. Now let me hit the submit button. There were some typos. This is fine, man. Anyways, yeah, you can clearly see here the sample test cases are, I mean, all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases. We have made use of the iterative DFS. As I went with the BFS, the last this one, last problem. So I went with the iterative DFS to solve this particular problem. Yeah, so you can just go with the BFS as well. It works flawlessly. So I just wanted to solve this one with a DFS actually. Basically DFS, you can just go with a recursive DFS as well. I just wanted to go with a iterative DFS. This is fine. So now we are done with the this one solution part. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.